Hello grade 12s, welcome to my channel. Let us do a part 2 of our Euclidean geometry revision for those who are going to be doing the upgrading, and of course it's a lesson for those who are going to be doing this perhaps for the first time. Right, so this is from the High Flyer document from KZN 2021. So this is the part 2 of our video. So the last time we stopped from question 11. Now we're going to carry on from question 12. Unfortunately, this branding by thermophysics is causing problems. Anyway, the statement reads, in the diagram alongside OM is the radius of the larger circle. Okay. So this is the radius of the larger circle, to mean that O is the center, right? And also the diameter of the smaller circle. So if this is the diameter of the smaller circle, we know that the angle at semicircle is 90 degrees, right? So this being the diameter to the smaller circle means ONM is 90 degrees. Okay, now seeing that this is the center of this larger circle, if any line from center is drawn perpendicular to the chord EM, it will bisect that chord, suggesting that EN is equal to NM. Alright, now I told you that chord EM of the larger circle cuts the smaller circle at N. If EM is 2x squared minus 2 units. Okay, so we have information that this is itself 2x squared minus 2 units. Okay, and ON is 2x. Okay, ON is 2x, right? Now we are to express, giving reasons, the length of the radius of the larger circle in terms of x. Okay, that's quite easy because we know that at the end of the day we're going to land up in this triangle, right? So we're going to have to use Pythagoras from here. Alright, so this is not too difficult. So let's start. First and foremost, we're going to say there's many ways, but we can just say O N M is 90 degrees, right? What is that? This is the angle in a semicircle, right? That's the valid reason for that. And this implies that essentially EN is equal to NM. Now this is the line from center perpendicular to chord, right? We know that a line from center when perpendicular to the chord bisects the chord. So these are the theorems that come in. Alright, so this further implies that basically NM is going to be equal to a half of EM. Or perhaps, what can we say? I think we've already done it, you know? Or maybe we can go on EM, which implies that our NM is going to be a half of 2x squared minus 2. Now we know that when we distribute the 2, we will have our NM equal to x squared minus 1. Alright, so this is essentially what we have. We can say then, we know that OM squared is going to be ON squared plus NM squared. This is Pythagoras in triangle ONM. Okay, right, so we go on. OM squared is going to be ON, this is 2x squared plus, this becomes x squared minus 1. Continue, OM squared equals, this is 4x squared plus, oopsie, I forgot there. This is going to be x to the 4 minus 2x squared plus 1. Right, and we continue, OM squared equals, now this is 4x squared plus, minus 2x squared, which becomes 2x squared plus x to the 4. In fact, let me write it properly. So this is x to the 4 plus 2x squared plus 1. Now we want to take the square root on the left hand side, and what we do, we must do it to the right hand side. So this implies that OM is going to be equal to the square root. Now we can see that this can be factorized. And how do we do it? We can do it like so. This is a sum of two squares, isn't it? So this is going to be x squared plus 1 all squared. Maybe this is too long. So please guys, don't forget algebra. It is still your friend. Okay. So therefore OM is going to be x squared plus 1 units. Nice and easy. So how do we score marks? The statement and reason. That statement and reason is powerful, and getting the value of NM is key. We can say here substitution into Pythagoras, that's the 4th. When we factorize that trinomial, that's the 5th, and then the 6th mark when we get our marks. Our answer. Alright guys, so this one was an easy question. No big deal in it. Right, let's get to question 13. Question 13 reads, in the diagram below, circle QPRT, and we can see that we see a cyclic quadrilateral because all 4 vertices of this quadrilateral are at the circumference of the circle. Now intersects SQ at T. SQ at T, wait, the circle, the circle intersects SQ at T, okay, that's fine. And SM at R. Okay, so these are seconds to the circle basically. And by them being named like this, already tells us that these are straight lines. Okay, please remember this. And specifically, they are seconds. Okay, now QM is parallel Okay, it's parallel to TR. There we are. And MP is equal to PR, so that's already indicated. And 2ST is equal to TQ. So if ST, we can call it maybe X. This should be, oh wait, there's more. We're told ST is A, so this means this is going to be 2A, okay? And SR is B units, okay? So not a problem. So what can we do here, guys? We know that without a shadow of doubt, R1 is going to be equal to Q2. Now that's the exterior angle of a cyclic quad. But that same R1 is equal to angle M. Why? Those are corresponding angles with these two lines parallel. Interesting stuff. Is there more? There is. We know that this angle is going to be equal to that angle. That's the exterior angle of a cyclic quad. Okay, that's about what we can say. Right. So we're not told that this is a tangent, so we won't talk about the 10 chord theorem. Okay, although we are inclined. I mean, we can see this line touches the circle at just one point, but it was not told to us as a tangent, or that it just touches at only one point. So we need to be careful. So let's go. 13.1. We need to prove that triangle SQP, okay. All right, so this is the big triangle. It's similar to triangle SMQ. The very big one. So basically we are comparing this shaded triangle and that smaller one. Okay, now let's see. We already discovered that this angle is going to be equal to that angle, which is going to be equal to this angle. Right, so those are going to be essentially equal, but we will see that angle S is common, so it belongs to both triangles. So if we've got two sets that are essentially equal, then we have it all done. So we will say in triangle SQP and triangle SMQ. What do we have? We know that angle S is common, right? Second, we know that Q2 is equal to R1. Now what is this? This is the exterior angle of a cyclic quad. We can even name it. Say this is QPRT. Okay, right. We say though, but we know that R1 is going to be equal to angle M. What is this? This is the corresponding angles with TR parallel to QM. So therefore, Q2 is equal to M. Now once we have two sets, we can make the conclusion that triangle SQP is similar to triangle SMQ. This is angle, angle. We don't need the third angle. It's automatically implied. Okay, so let's see what is the story here. Statement and reason, most likely 2 marks. Corresponding angles, maybe. This conclusion was key. The final answer with the reason, 1, 2, 3, 4, 5. Okay, looks like everything gets a mark, but again, it doesn't matter. If it is 6 marks, we take it. We don't cry. So 13.1.2. Now we need to prove that this is the case. Now with these ones, we look at this sides. Where is QM? QM is here. It's the side of the big triangle. QP, where is it? QP is essentially also the side of the smaller triangle. So it means we are comparing these two triangles. Okay, so now we have to prove that this is equal to 3A over 2B. Okay. That looks a bit strange, but we will see about it. We will see about it. Okay, this question is one of those. It's one of those. It's one of those. Aibo. What is this now? It's one of those higher grade questions. So you can already see that we have a situation that is somewhat out of control. Anyway, we know what to do. So let's get to business, guys. So what we're going to start saying is we can decide to work on the big triangle alone, because the big triangle we've got, you see the big triangle, we've got TR drawn parallel to that side. So that means those sides are cut in the same proportion, so to speak. We can play with that and see what happens. We're going to say in triangle SQM. What do we know? We are interested in finding out one of these sides. Okay. I think we need, essentially we need this side, because this is the side that we want, RP, so that it's part of this nice small triangle. Okay, so we're going to say essentially ST over the whole of TQ must be equal to SR over RM, right? Now this is the proportionality theorem with TR parallel to QM in that named triangle. Alright, so this implies what we want, ST is A divided by TQ, which is 2A, equals SR, which is B, divided by this RM. But now RM, since it was given to us that MP is equal to PR, we can easily say this RM is 2 times RP. Right? We know that we were told that MP is equal to PR. So that's why we are doing that. Okay. Now we know that A we'll take A, and we can cross multiply and solve problems. All we want is to isolate. We want to isolate RP. So this implies that 2 times RP is going to be 2 times B. Now, when we divide by 2, in fact, why do I even want to do it? So therefore, RP is equal to B. Because when we divide by 2, RP becomes B. Alright, so what do we say? Then, we know that we can use the proportionality of these sides because now we want QM divided by QM is opposite that angle, and this angle on the smaller triangle is essentially opposite QP. Must be equal to, so we're going to choose the sides that we know. So I'm going to choose SQ over. Now SQ is opposite this angle. In the other triangle, that is the angle, the side opposite that is SP. So what is that? This is similar triangles in 13.1.1, just to try and be specific. Okay, now folks, this is nice and easy. So this implies that QM over QP will be SQ. It's 3A, isn't it? Because we're going to add all of those values, divided by SP. Now SP is 2 times B, isn't it? We proved that RP is B. So now SP is going to be B plus B, which is just 2B. Right. Is that what we're supposed to prove? Yes. So this is essentially a conclusion. Okay. Not so bad. Don't know why 6 marks. Doesn't look too complex. But we can say statement and reason. Yeah, that's very important. And to prove that RP is B, that's good. And of course, statement, maybe, and reason. And then we can say the substitutions here. Otherwise, the answer is part of the substitutions. Okay, so that's 6 marks in the bag. Rather ridiculous, but we take it. So let's see, we've got 13.2. Now 13.2 says it is further given that triangle QPT, okay, this triangle here, if we can just staple it so that you can see it. So always annotate in such a way that you can see where you are. Sometimes these drawings can get very overwhelming. Okay, so that's the triangle we're talking about. It's similar to triangle MPQ. Okay, right, so MPQ, we can also annotate it in such a way that we can see it, you know. We can give it blue stipples. We can stipple it blue, black and blue. So these are the 2 triangles. The one with blue stipples and, you know, but I think the stipples are not really doing a good job, are they? Nah, they are not. Let's find a better way. All right, so there's our triangle. We can see it. It's much better. Now, what are we going to do, guys? Obviously, we know that technically, if the examiner gives us the triangle and that these are similar, it means the angle Q in the one triangle is going to be equal to the angle M in the other triangle. And then the angle P is going to be equal to the angle P in the other triangle as well. And this also means T is going to be equal to the angle Q in the other triangle. So let's go and check that out. Usually this format is good, but be very careful though. Let's look at it. Q in this QPT is that angle. Indeed, it is equal to M in the other triangle, so that's good. So this means this side corresponds with that. Okay, that's not a problem. And then what else do we want to say? All right, no problem. And then it means P, which is going to be P2, must be equal to this P as well. Okay, no problem. And essentially, this means that side will correspond with that, as this one will correspond with that, and these two are just doing it. Okay, all right, okay. And of course, angle T, which is that angle, should be equal to the angle Q of the other one, which is this one. Okay. Actually, what I said was incorrect. It was incorrect. Incorrect. So this side of this triangle corresponds with that side because that angle goes to lie there. This one goes to lie there. So this means this side will correspond with that side. Okay. So again, this is another thing that students, you need to know how the triangles are named in general, especially by the examiners, is such that the angles that correspond, when there's similarity, they should be equal. But be careful, double check. Sometimes things do happen that it is not named according to this format and you end up in trouble. But I mean, I think when this is given, I suppose the standard way of naming becomes compelling. 13.2.1 says, now we need to prove that QM is the tangent to the circle. So obviously we saw that this angle, that angle would correspond with this, right? And if that angle is equal to this, then it means this is the tangent, converse of the 10 chord theorem. So very easy. So first of all, we're going to say Q1 is going to be equal to T1. Now these are the corresponding angles of similar triangles in 13.2 that was given. So we can say therefore QM is a tangent to circle QPRT. Now what is the reason here? We talk of a converse of the 10 chord. Theorem. Okay. So obviously the reason is important here. And here the statement and reason, I think it's more powerful. We get our 3 marks, we move on. So 13.2.2 says we need to prove that TP is equal to 4B over 3. So where is TP? TP is this side. Okay. So it's the side of the two similar triangles. No problem. So let's get to business. We know that if we start there and say TP over. Now TP is opposite this angle, but that angle is equal to that, so the side opposite that is going to be essentially that, right? Emanyan. Yes, TP is opposite that. That angle is equal to this, and the side opposite that is QP. Okay. This is equal to, but do I want QP? Okay, QP is there, so I can use that statement above. Okay, good. And then I want to choose a side that I know, so that should be TQ over. Now TQ is opposite P2, and we said P2 was going to be equal to P3, and the side opposite that is QM. Okay, and again I've got QM over there, so I can use that. So we can just say this is similar triangles. Same similar triangles we just proved, or at least we were told, in 13.2. Nice and easy. So folks, we go on. So this implies that TP over, actually, let's make it easy. We just cross multiply and isolate TP. So this implies that TP is going to be QP times TQ all over QM. Okay. Now, what is TQ? So this implies that TP is, now obviously this is this situation reversed, isn't it? Because we can see that we've got QP over QM times TQ, isn't it? Yes, so this implies that TP is equal to, we just invert that, it's going to be 2B over 3A. TQ is 2A. Nice and easy. So this A takes that A, and we end up with TP equals 2 times 2 is going to be 4B divided by 3. Nice and easy. No stress, no struggles. Of course, it takes knowing what to do. All right, folks. For this one, I think statement and reason is powerful. And to invert this guy from above, that's good. And we can even say the general substitutions. Whatever, guys. At the end of the day, the work is done. Easy 4 marks. We move on. So how many marks was this? This is 10, 16, 18. Wait. Yeah. 18. So this is typical of those, end game type of questions. I hope you guys were able to follow, and let's move on without wasting time. So we're going to do question 14. Now 14 says, in the diagram alongside, PWT is a cyclic quadrilateral, right? This is obvious. And we're told also with WU, right? This is equal to TU, okay? If that's the case, it already tells us that these angles are going to be equal, right? So those are angles opposite equal sides in that triangle. Chords WT and PU intersect at Q. We don't see a Q, but we can see where they intersect, so this means this is Q. Sometimes certain things are not written, guys. You need to be able to see that, and this is left deliberately so that you'll be like, there's no Q. but the statement is telling you these chords, you can see PU and WT, they intersect there, so that should be point Q. So don't always expect everything is going to be on the diagram. Read the statement, check the diagram. If it's not there, you add it. If it is there, you accept it. Okay, PW is extended. Once we extend a line or produce a line, it means it's the same straight line to S, such that SW or US, US, not SW, it's parallel to TW. So this is already indicated. Alright, so if this is the case, guys, you already know that this angle is going to be equal to that angle. Those are corresponding angles. And we can already appreciate that this very angle S2 should be equal to that angle. Why? Because these are alternate angles. Now we can see that if U1 is equal to T1, then this means this SU must be the tangent. Yes, it's not given, but we can already prove an issue about tangency. And then, of course, guys, there's lots of angles that one can say they're equal. See, T1 should also be equal to P2. These are angles in the same segment subtended by chord UW or arc UW. There's plenty. At this point, you don't want your diagram to be too busy. As long as you've highlighted a few issues, maybe they might help, maybe you might have to look at the diagram again. Now let's prove that US is a tangent to the circle. Can you see we already have by just annotating our diagram? So the target now is to truly prove that this angle U1 is equal to angle T1. So first of all, I'm going to say, well, U1 is equal to W2. These are alternate angles with WT parallel to SU. Right? That's the first thing. We're going to say, but I know that W2 is equal to angle T1. Why is that? These are angles opposite equal sides of triangle TUW, given that WU was equal to UT. It helps to really say as much as possible. Another person may choose to just say, for this reason, these are equal chords. In a circle, equal chords. You can just say angles subtended by equal chords. Right? Given that WU is equal to UT. So that's the alternative reason that a student can provide for such a situation. All right. So folks, now we are good, because we now make the conclusion that actually U1 is equal to T1. Now, of course, each equals W2. That's if you've lost the track of it all, but it should be easy. Now we can prove that US is a tangent. Okay, to circle PWUT. Right, what is this? This is the converse of the tan chord theorem, isn't it? Normally we get told that SU is a tangent, and we can then deduce the angles to be equal. But now we found that the angles were equal before we were told. So this means conversely, SU should be the tangent. Easy stuff. So, getting 5 marks. How is that? Well, we can say first, the reason here is important. And the link is important. That statement is good together with the reason, but this one, I mean, all of these we can decide. We get 2 marks for one and then 2 marks for the other, 1 mark for the, it doesn't matter, guys. 5 marks is in the bag. For me, this should have been just 4 marks. Anyway, so 14.1. Hey. 14.2 says we need to prove that SPU, where is it? So there is our SPU. Okay, we need to prove that it is similar to SUW. All right, so we are comparing this nice green outlined triangle and that yellow shaded triangle. Okay, that's not a problem. In triangle SPU and triangle SUW. So we can already see that angle S is common. Okay, so that's nice. And then what do we have, guys? 10 chord theorem coming up. Do you see now that we've proven this is a tangent? You can just say U1 is equal to P2. Right, of course, we can say P2 is equal to U1. So we know that P2 is going to be equal to U1. At this point, this is the 10 chord theorem. Since we've proven that above, US was the tangent. Now, folks, as I said, if you prove 2 sets, you are good. So you can just say, therefore, triangle SPU should be similar to triangle SUW. This is good enough. Do not feel you are running short of anything. So you're getting 4 marks. Well, statement and reason, the reason, and then the other statement. Nice and easy. This would be 3 marks technically, but 4 marks is not a problem either. So 14.3 says, oopsie, we're gonna get one of those issues of trouble in paradise. Now I need to prove that SU squared is equal to QU. There is QU. Okay. And there's a PU also. Oopsie. So there's the stuff. So we've got PU, we've got QU, and then there's SW squared. So there's the stuff now. How did that guy end up being squared? Remodulo. Okay, it's 6 marks. But don't be scared. It's never really too bad. All I know is that we are looking at this nice green outlined triangle. This side is drawn parallel to that. So we can do something about that proportionality theorem business. But at the same time, we've got these 2 triangles we just proved similar. And of course, the 10-second theorem will already tell us that the square on the tangent is going to be this product of SW and SP. Of course, we can use similarity for this, or we can just say 10-red theorem. It is up to you, but I'm going to try and be reasonable and use the similarity we just proved. So first and foremost, guys, we know that SU over SU is opposite this angle in the big triangle. That angle is equal to U1 in the yellow one, and the side opposite that is SW. That is going to be equal to. Now I'm going to choose strategically a side on the big triangle so that it corresponds with the side SU on the smaller triangle. But the nice thing is I do not have a choice. PW is already giving me the vibes. Sorry, not PW, but PU. PU is opposite that angle. That angle is common, and the side opposite that is UW. Okay? So it doesn't help me. Hi-bo. Hey, Unketsang. I lied. Did I lie? No. Hi man. PW 10 ungayenzi ngokulento. Sungiqhela wena. Skandlwayela wena man. Skandlwayela man. Doch, what is this now? Ke eng piano ntwena? Ke eng jwale? I don't want WU. No. U is not my friend. Now let's check, what can we divert to? Well, we're going to choose SP instead. I think PU. Tatile ngwana motho ke a bona o ntse o le teng empa a re o batle ha. Nako ena ha se ya hao, ya tla ya hao emanyana. SP is opposite this big one. Of course, this big one would be equal to W3. The side opposite that is SU. Okay, we can say this is similar triangles in 14.2, isn't it? Is 1, and then we cross multiply. So we will see that SU squared is going to be SP times SW. Now the enemy to progress is SP. Now we know that we can use that proportionality theorem. We're going to say, well, but we know that SP over SW is going to be equal to PU over QU. Right. Now this is the proportionality theorem, prop theorem with WQ parallel to SU in triangle SPU. Okay. Now, what do we know? We just cross multiply that. We can appreciate that essentially SP becomes PU. It becomes PU times SW divided by QU. Right. Okay, so what do we do now? We can say then, maybe let's finish it up down here and let's just take the whole thing even so that we have some continuity. Now we have a story to tell that then we know that SU squared equal to SP times SW implies that SU squared equals, instead of SP we put PU times SW, then times SW. This is all divided by QU. So this implies that we've got SU squared is equal to, now we're going to have PU times SW squared all over QU. Now this is over 1. We cross multiply again. We can now make a conclusion that SU times QU is going to be PU times SW squared. The issue has been sorted. So strategy, guys, strategy. Sometimes just remember simultaneous equations, but that's what we are doing here. We have essentially taken equation 2 and substitute it into equation 1 to get equation 3, if you will. So simultaneous equations, don't forget the concept, it still comes back. Well, we're getting 6 marks. So I would say, well, this is good, 2 marks. I think the statement and reason is compelling. The substitution here, 1, 2, 3, 4, 5. Yikes, 6. Well, the answer was given. So, I don't know. I do not know. Sometimes you get a mark even though the answer was there. We had to manipulate quite a lot to get to it. So it was not so obvious. Maybe. Okay, guys. So that's the story about that question. So we have 15 marks to smile about. And we move on. Right, you know what, guys, I am supposed to have a class with my students. It's 7:30, and I'm a bit worried that I'm hemorrhaging time. All right, I just thought, guys, I need to order some food. I'm not gonna be able to cook now. I forgot that actually I have a class at 7:30. Now if I start cooking now, I'm not gonna finish on time. Anyway, let's get to this question. In the diagram below, P, A, Q, R, and S lie on the circle. So what do we call those points that lie on the circle? This one, that one, that one, that one, that one. We call them concyclic points. And you can see that any 4 of them that form a quadrilateral, it becomes a cyclic quad. So as you can see, this becomes a cyclic quad because all 4 vertices are its circumference, okay? So that's good. Let's read on. And of course, we're told O is the center of the circle. So if O is the center, what do we know? Okay, we know that AOS becomes the diameter. So what do we know about a diameter? It subtends a right angle at circumference. Okay, now we're also told that SB touches the circle at S. What do we know? A straight line that touches becomes a tangent. So that's another way of saying this is a tangent. Okay, all right, okay. So if that is a tangent, so this means we have an angle of 90 degrees also. 10 red. Issues there are kicking us in the face, and we can even say this angle must be equal to that angle. 10 chord theorem, because that's the suggestion. Okay, so let's leave that for now. We're told RW is equal to WP. This one is equal to that. Now we know, folks, that if a line is drawn from center to the midpoint of a chord, it is perpendicular to that chord. So we can say safely this is 90 degrees as well. And if this happens, we can see that corresponding angles are equal. So it means these lines must be parallel. See, working on the diagram, guys, reveals everything. And of course, we can already see that this angle is going to be equal to that. They are alternate angles, and this angle is going to be equal to P3. They are also alternate angles. Now, if P3 is equal to P2, this also suggests that this side must be equal to that side. So a whole lot of info just sprang out. Just like that. Anyway, once the diagram gets a bit busy, you stop. Now we are also told that AOWS is a straight line. Okay, we perhaps needed to hear that before I concluded that AOWS is going to be the diameter. Okay, now 15.1 says we need to prove that SB is parallel to RP. We just did. Now how are we going to use it? We're going to use the line from center to midpoint, so that this is 90 and 10 rad 90 corresponding angles. We're going to use that. So we're going to say fine. We know that basically W, what can I say? Let's just say S1 plus S2 must be 90 degrees, right? Why is that? This is the tangent perpendicular to radius. Okay, that's what we know. Second, we can say likewise, although not the same, we also know that O at W3 is going to be 90 degrees. Why? This is the line from center to midpoint of chord. We know that it is perpendicular to the chord. Now we know that essentially S1 plus S2 is equal to W3. Each is 90 degrees. If that's the case, we can now make a conclusion that indeed SB is parallel to RP. Now what is the reason? Is that alternate, not alternate, but corresponding angles are equal. So when corresponding angles are equal, it means there's parallel lines involved. Okay, nice and easy. Not a very difficult proof to do, but one that needs your eyes opened. So 5 marks, we can say statement reason, the final reason for the answer. Nice and easy. So let's do 15.2. 15.2 says we need to prove that RS squared is equal to WS. Okay, so RS squared, we want to say that this is going to be WS times AS. Okay, right, so what I'm looking at here is I mean this is 8 marks. So for 8 marks, it looks like I need to prove similarity. Okay, I need to prove similarity. 1. So it looks like I'm comparing this triangle and the smaller one. So these are the two, the yellow shaded triangle and the blue outlined triangle. Let's get to business. Sometimes you don't want to hesitate. We just get to business. We're going to say in triangle RSW and triangle APS, you know, the APS score. I don't care how I name them. You may have to care. It's fine. All I know is that I know the work, guys. So what do we know, guys? We know that that angle R2 is equal to angle A. These are angles in the same segment subtended by chord PS or arc PS. Okay, that's the first one. So we can say, well, R2 from the small triangle is going to be equal to angle A in the big one. These are angles in the same segment. Okay, easy. Second one, Well, we know that this angle is 90 degrees. It's an angle in the semicircle, but this one is 90 degrees because of the tangent perpendicular, the line from center to midpoint of chord. We can even use that reason easily. So I can say, well, for the small triangle, I know that W4 is 90 degrees. I can just say line from center to midpoint of chord will be perpendicular to the chord. Easy. And then, there's other reasons. You can use co-interior angles or angles on a straight line. It's up to you, really. I don't have to say it. So also, what do we know, guys? We know that basically APS is also 90 degrees. This is the angle in the semicircle, or in a semicircle. Angle in a semicircle. You may like to say semicircle. So what we want to say, guys, is to prove that W4 is equal to APS. Now we've got two sets. We can make a conclusion that, well, triangle RSW is similar to triangle APS. We've proven two angles to be equal. The third pair will fall into place. So what do we want to say, guys? We can say then we want to take the side RS divided by, now RS on the small triangle is opposite the 90 degrees, and that is also equal to that angle APS on the big one. The side opposite it is AS. As I said, the sides that make up the ratio are the sides opposite the two equal angles in the two triangles that are similar. Now we go on and say, fine, WS is now automatically in the house. WS is opposite R2. R2 equals A. A is equal to PS, or whatever SP. You can just say similar triangles, or proportional sides of similar triangles. Now, what do we know, guys? We know that, hey, however, we know that we have somehow proven that these two angles were equal. I don't know if we spoke about them, did we? No. Okay, this is what makes this question so long, because now we can't just jump in and just say they are just equal. So now I need to know that, well, however, I know for a fact that R2 is equal to S4, right? This is the 10 chord theorem, right? Now, also, okay, I know that S4 is itself equal to P3. These are alternate angles with the two lines we proved parallel at the beginning. So it's SB parallel to RP. So what can we conclude? We can conclude that R2 is equal to P3. If this is the case, we can then prove that RS is equal to SP or PS. Let's just say PS. All right. Now, what is the reason here? These are the sides opposite equal angles in triangle RSP. Another student may just say these are, can just say chords subtending equal angles. Because these are chords of the circle. So when chords subtend equal angles, then those chords are equal themselves. All right, okay. Now that was a bit of a crazy detour, was it not? We can say this implies that RS over AS is going to be equal to WS over, instead of this we put RS, cross multiply, we make a conclusion that indeed RS squared is going to be WS times AS. Okay, that was a bit of an essay, but we can take it. It's worthy. It's worthy of, you know. So this, right, that, right, and then this conclusion, yes, the statement and reason, quite important. The 10 chord, so 1 2 3 4 5 6 7, ha 8. Okay, senigeze too much. I cannot give more than 1 mark there. So this is 1 2 3 4 5 6 7. Substitution, I think, then 8, but of course the other mark could be considered for that. Anywho, 8 marks in the bag. Yeah, Euclidean. There's a smaller one there, 15,3 says we need to prove that AS, where is AS, this guy, still, is equal to W, whatever this is, yikes, RW squared. So this features this side, and then WS still there, and WS. Okay, that looks scary, but we're going to think about it constructively. We're going to think, what if we use this proof right here? If we use this proof, we already have a square on RS. Now RS, in terms of this triangle, what is it going to be? Pythagoras, right? RS squared is going to be RW over W. See, we're going to say, well, we understand that AS, so we're jittering it. We know AS times WS is equal to RS squared. This is proved above. Okay. We will say, but we know that RS squared is equal to RW squared plus WS squared. This is from Pythagoras in triangle RSW, isn't it? It's a right angled triangle. So then we know that, well, AS times WS is equal to RS squared, implies that AS times WS is going to be RW squared plus WS squared. Right, so we're just substituting there, and then we divide by WS throughout, so we get AS is equal to RW squared divided by WS plus WS squared divided by WS. WS takes the square and it's done. So therefore AS is RW squared over WS plus WS. Oops. As you can see, guys, algebraic manipulations will always be involved. All right, let's move quickly, guys, because I'm losing time very fast. I think the statement becomes important. The substitution becomes important. And I mean, this should be 2 marks, you know. But I guess they would say statement and reason. And of course the manipulations, although the answer was provided, I suppose how we came about it makes sense. Okay, all right, okay. Now let's get to question 16. I wonder if I'm going to be able to finish these questions. Question 16 says, in the figure, D is the midpoint of AB, so that means this side is equal to this side, and E is the midpoint of AC, so that means that side is equal to that side. So this would mean this must be parallel to this side, isn't it? Midpoint theorem. Right, DC and EB intersect at right angles, so DC and EB. So we are being told that this angle here is 90 degrees, and all of these angles, of course, this being vertically opposite, there's going to be 90 degrees, and you know, this is going to be 90 degrees. I just want to step it out a bit so that there is a bit of stepping, and then that would also be 90 degrees, isn't it? Maybe I'm papela. So this is going to be 90 degrees. So there's just 90-degree triangles there, essentially. Okay. Right. We are also supposed to prove some crazy stuff here for 8 marks. Okay, let me put my lights on. Okay, so we need to start working. All right, so I'm looking at, there's AB squared here. Where does it come from? AB is this side. But how does it become a square? Well, maybe through DB, isn't it? Because DB is half of AB, so maybe we're looking at that triangle DB. Then AC squared as well. Excuse me. AC squared is from here, so surely through EC. It should give us something. So this makes us to look at these 2 triangles. So those 2 triangles are seemingly giving us something. Okay. All right, okay. Now we're gonna start. Let's see. How do I begin this? Anyway, let's just say, to begin this attack, I'm going to say OB squared. Is it OB? So the hypotenuse side is DB. So I'm going to say DB squared is going to be equal to DO squared plus BO squared. This is Pythagoras in triangle. Oh, guys, I'm not doing well. In triangle BOD. Okay, so that's essentially what I know, which is going to imply that, what is DB? DB is half. So this implies that I've got half of AB, all of it squared, equals DO squared plus BO squared. So this implies that I've got AB squared over 4 equals DO squared plus BO squared. Therefore, I can see that my AB squared is going to be 4 times DO squared plus 4 times BO squared. Right, when we cross multiply. Okay, that's fine. We leave it here. What are we going to say? We are going to say likewise. Likewise, we know that EC squared is going to be OE squared plus OC squared. That's Pythagoras in triangle COE. Right, so this implies we know that EC is half of AC. We are squaring it. So OE squared plus OC squared. So this implies that AC squared over 4 is going to be OE squared plus OC squared. Therefore, AC squared is going to be 4 times OE squared plus 4 times OC squared. Now we're going to go on and say then we know that AB squared plus AC squared is going to be 4 times, is it DO? Did I say DO there? Or, yeah, I said DO. This is 4 times DO squared plus 4 times BO squared plus 4 times OE squared plus 4 times OC squared. Ooh, kwavele nje kwayinyaka. Okay, let's see. How does this one take us to BC? If we want to end up with BC, we know that if this is 90 degrees, BC is going to be made up of the square on OC and the square on OB. Yeah. Okay, so we need to group things. So this implies that AB squared plus AC squared equals. Now let's take BO. We know that 4 times BO squared plus 4 times OC squared, we're grouping these, is going to be added to. Now what do we see there? We see DO squared 4 times DO squared plus 4 times OE squared. Again, we can group those. But if we do that, we'll see that this squared plus that squared is going to give us that one squared. All right, so we factorize nicely AB squared. We factor out the 4, we end up with BO squared plus OC squared plus 4 into, now this is going to be DO squared plus OE squared. This implies that AB squared plus AC squared equals 4 times. What is that? We see that this is BC squared. Pythagoras in the other triangle. We don't want to explain it anymore. This is going to be 4 into. This one is basically DE squared. Pythagoras in these other triangles. So this is this triangle that we are talking about. Right. And this triangle. Okay. Nice and easy. Now we need to get rid of DE. So we know that from midpoint theorem, DE is half of BC, isn't it? So we can say this implies that AB squared plus AC squared is going to be equal to 4 times BC squared plus 4 into. Now DE itself is nothing but half of essentially BC all squared. And then here we may have to say midpoint theorem with essentially midpoint theorem, guys. I see. Let's not say a lot. It's the midpoint theorem. And then we go on. This is AB squared plus AC squared equals 4BC squared into 4. Now this becomes BC squared over 4. Now this takes that, and then we have AB squared plus AC squared equals 4BC squared plus BC squared. Therefore, this is going to be 5BC squared. Proof done. Okay, now these are killer questions. As you can see, it takes you an essay to get to this one. So we're getting 8 marks. Okay. All right, I think this substitution, matters. And this equation, I suppose. Maybe this one. So we've got 3 marks there. And then when we group these and factorize, first the factorizations is a mark. Maybe we can mark also that, but it's stupid after all. So 1, 2, 3. Okay, just a moment, guys. All right, guys, we're still counting 1, 2, 3, 4, 5, 6, 7, and of course 8. I don't know, guys, there's just too many marks at the moment, but yeah, it is what it is. It is what it is. So as you can see, some questions can be quite heavy. They can be quite heavy. This is one of the killer questions where you have to keep composed and work as hard as you can. Let's rush through question 17. Okay, guys, I don't know. I'm looking at the time. It's not so favorable at all. Yikes. Because my class is about to start and we've got quite a few questions to go through. I wonder if we're going to make it, but let's see what happens. I'm going to try to move as fast as possible. Right, in the diagram alongside K, M, N respectively are points on the sides of PQ. So we can see that PR, QR in triangle, you can see that. And we know that KP is 1,5, so it's indicated. PM 2 indicated. KM is 2,5. That MN is 1. And MR is 1,25. And then NR, so all indicated. Good. Then we need to prove that these two triangles are similar. Well, we're going to use proportionality here. So sometimes you get given the sides. Now, once they're in the same proportion, then we are in. Okay, let's say in triangle KPM, right? And triangle RNM. Right, so what do we see there, guys? Well, we're going to be strategic this time around. We know that 1,5 divided by 2 is going to be 0,75. Yes, and then we're just going to use their sides to be in the same dons. So we're going to take say KP over, of course, NR is equal to, wait, konje siyenza kanjani? Yeah, injalo man. And then let's see, this is going to be 1,5 divided by 0,75. I don't know why, guys, I'm doing it this way, but it is what it is. So therefore KP is going to be equal to basically 2 over 1, isn't it? Where's my calculator? This is 75 over 10, no, over 100. Right. And then this is 15 over 10, isn't it? So 15 over 10 divided by this is going to be the same as multiplying by 100 over 75. 10 once, 10 times 200. And then 15 once, how many times? 275. 5 times. 15 by 5. Because 15 by is 60 by 575. Yeah. So we end up with 10 over 5. Yes, this is going to be 2 over 1. Right. Can say also, we know that, of course, guys, this one is going to be a bit ridiculous, but what can I do? I'm going to say PM over, what is the side that corresponds with PM is MN. This is going to be 2 over 1. Right, and of course the last one, we can say likewise, we know that also MR, what's going to be MR? It's going to be PK. Did I say PK? No. It's going to be KM divided by MR. Right, so that is going to be 2,5 divided by 1,25, which is also going to be 2 over 1. Kabilo can say, therefore, we know that KP over NR is equal to PM over MN, which is going to be KM over MR. Can say, therefore, triangle KPM is indeed similar to triangle RNM. Can just say the sides are in proportion or in same proportion. Easy. As you can see, guys, some questions are a bit ridiculous. You need to be very strategic about it. Check very well. Just don't want to waste time here. So what is the story, guys, here? Perhaps we could just get a mark for this, and then for saying all of them are like that, final answer with the reason. It's a ridiculous question after all, but hey, it comes. And when it does, we deal with it. So 17.1 is done. So 17.2 says, we need to now calculate the length of QN. Well, if we look at that, QN is over here. So how will we find QN? So this is already trying to suggest that we need to prove yet another form of similarity. Okay, so if we just proved that these are similar, what do we know? We know that this angle is going to be equal to that angle. Why? Because the ratio that is made by those sides, you see this side is opposite P, which would correspond with that side which is opposite that angle. And then the other one, we're going to say this angle is going to be faced with 1, so that means it's equal to that angle. Right. Goodest. That one is going to be equal to this one. Okay. So that's the corresponding angles of similar triangles. Easy. So we're going to use this as a means to an end because I'm thinking of the big triangle and one of the small ones. Let's see. So if you check, guys, you will see that if we compare that small triangle with the big one, what do we see? You see that angle is equal to this, right? And this angle is common. So these are similar, nice and easy. So we're going to use this nicely. We're going to say in triangle, we can say PQR and triangle MNR. What do we know? We know that angle P is equal to angle MNR. Now these are the corresponding angles of similar triangles in 17.1. Right. We can say here angle R is common. Right? Therefore, triangle PQR is itself similar to triangle MNR. Angle. Now, what else can we say? It means then we know that from the big triangle, QR as a whole. Now remember, QR is opposite that angle. That angle is equal to that. The side opposite that is going to be MR. Must be equal to, we're going to choose a side that we know fully. It's going to be PR divided by, now PR is opposite that angle. That angle will be equal to that. The side opposite that is NR. Now, what do we say? These are similar triangles. Their sides are in the same proportion. Wow. Okay, guys, so it came back. So now, what do we want? We want QR. So this, we cross multiply. It tells us that QR is going to be equal to PR over NR times MR. This also implies, what is QR? It's QN plus NR, which is 0.75, equals PR. PR is going to be 3.5. No, divided by NR is 0.75 times MR, which is 1.25. I would like to finish it here still. So I want to make QN is going to be equal to, you transpose that. So let's see, where's my calculator? Heaven, Kanti, what happened to my calculator? I don't want to struggle. I know how to do this without, but why should I suffer? There it is. Damn it, man. Alright. So guys, I'm gonna move quick so you know what to do there. So it's gonna be 3.5. And let's start. It's gonna be 3.5 divided by 0.75. times 1,25 plus 0, sorry, not plus, but minus 0,75. And then this gives us an answer of 5. Where's my pen? Yo. I'm getting a 5,08 units. Because we were not told if this is meters or what, we're just going to say units. Okay, it's not a difficult question, but it's one that demands you to realize what is needed. Okay. Right, so let's get the marks in the bag. This is good statement to give. And this is also good. And the statement and reason is important. The substitutions and the answer. Easy 6 marks. Nice, 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 guys. So we've got 17.3. I don't know, guys. I don't think we're going to do the other questions because my class is about to start. We have 1, 2, 3, 4, 5, 6. I think we're going to have to cut it and then maybe do those ones alone. Right, so 17.3 says determine the numerical value of triangle KPM, area of triangle KPM, divided by area of triangle RNM. Now we're definitely going to use the area rule. So KPM and RNM, we know that these are similar. So we're going to have to choose. But this one is weak. It's definitely weak. So this is going to be half. KPM, I'm going to choose angle P. So it's going to be half KP or PK times PM times the sine of angle P divided by 1/2 times the corresponding sides there. It's going to be NR times NM or MN times the sine of MNR. Right, did we ever mention that? Yes, we did above, so we are good. So already we know that we mentioned that angle P was equal to angle MNR above. The half takes the half, so all we have left is PK, which is 1,5 into PM, this is 2 divided by NR, this is 0,75 into 1. Now let's see. This is just 4. The ratio has no units, isn't it? Injalo. So 1,5 into 2. Yeah, divided by 0,75 is 4. So guys, you get a mark for writing the rule and for the answer. The rest was given. So how many marks was this? 8, 11. So of course, guys, you can see some questions look a bit ridiculous, but there's easy marks to score if you just know what to do. Oh, Nkosinofe, ndinewari, iklasi yami izoqala, ndizogqiba yini na? My class is about to begin. But then they don't come early anyway, those guys. I think I can postpone it and tell them that we're going to start at 8. Okay, I'm going to leave this space for someone who wants to write some notes on this. Because I don't want to do another video, I don't think I'm interested. All right, let's do this question. Now, that was question 17. We're going to make this one 18. Okay, I'm adjusting it because this one says 1, but there's no 1 here. So I'm going to say 18, 19, 20, 21, 22, 23. Okay, right, I'm gonna share this document with those numbers so you will know which questions are those. So let's see. In the diagram alongside CD is parallel to NH, yeah. NH intersects DE at G, we see that. K is a point on DE with DG equal to GK, so that's also indicated. HK is parallel to FE, so that's true. Then CN to CE, CN to CE is giving us the vibes of, this is 2:5, so this is going to be 2x, this must be 5x, in which case this tells us that if we say 5 minus 2, we get 3x. Okay, work out things, guys, don't wait. But of course, choose some multiple because these are not true units, but portions of a particular unit. Now, let's get to business. We just have 2 questions. One says, determine EK. EK. So this is what we want. EK over KG. So that's what we want. Okay. How are we going to do this? We're going to do it like so. Okay, it looks like we need to use this triangle. Let's start. 1.1, or let's say this is 18.1, right? So what do we want, guys? We're gonna say first in triangle CDE. Okay, let me just communicate with my group and say we're gonna delay this up until 8 because I'm a bit worried. Okay, anyway, someone is already asking for the time. Okay, let me just pause a bit. Okay, guys, so let's continue. I've just communicated that, yeah, it's going to happen like that. Now, let's see, guys, what happens here. Well. We don't explain much. We're going to say here, we know that GE, right, over GE over DG or GD must be equal to EN over NC. This is the proportionality theorem with NG parallel to CD. Okay, that's the first thing we're going to do. So this implies that GE over GD is going to be equal to, now EN is going to be basically 5x minus 2x. Of course, guys, you annotate the sketches. You are always provided the sketches. Here we don't explain anything. We just go. Okay. Divided by NC. This is 2C, 2x, right? Right. So therefore, we know that GE over GD is going to be, this one is going to be 3x. It's going to be 3 over 2. Right? Right. So this means, guys, what we have here is 3b, right? GE, and then this one is going to be 2b. Because remember, this is a ratio, so this is what this means. Right. Now I'm thinking, if we already have 2b here also, then it means the remaining part is just going to be b. Ay, ya ndixaka nanzi indaba. Okay, guys, this one is ridiculous. Excuse me, I'm not too sure how to get around this BSF8. But we can say GE is gonna be okay, I'm thinking of a better way to get around this business. I'm trying to find a better way. Hey, guys. Yaze yandixaka nansi indaba. I'm trying to think, Buffett, what is the best way to do this? Okay, so maybe let's just cross multiply this and say therefore GE is going to be 2/3, not 2/3, but 3/2 of GD. Okay, just want to use GD as a means to an end. We can say then we know that EK over KG or whatever, GK, we're gonna go directly. Now EK is GE minus GK, isn't it? EK is GE minus KG, all divided by all divided by KG. Okay. Right. So this is equal to GE itself is 3/2 GD minus KG is nothing but GD, because we're told they are equal. We're moving, all divided by KG. Again, KG is nothing but GD or DG. What did we write? GD. Ziyalingana, guys. So we are moving. So 2 times there, this is going to be 2. So 3 minus 1 is going to be 1. So we end up with GD over 2. This is divided by GD. Now this simplifies to GD divided by 2GD. This is going to be a half. Oop. Mathematics, guys. Mathematics. You see, most the mathematics is mathematicking. It is doing the maths. You get it. You do. Yeah. So we are playing, guys. We are playing the tricks. As you can see, I chose the very naughty way, but you could have done it another way, you know, there's plenty of ways to kill a cat, but I wanted a nasty old way. Maybe let's say for that statement and reason, 1 mark. And then this question is not nice, eh? Okay, this one, hey guys, hey Bonangeleto. That means all of the other things are your problems, not ours. Why, wow, even that GD is somewhat a means to an end. I think everything makes sense in this step. Okay, as you can see, it looks easy, but it's a naughty question. It is done after all. The next one says, are we able to squeeze it here? So 18.2, we have area of triangle DGH over area of triangle DEF. Okay, DGH is this one. Is that one? And then where is this other one? Where is this other one? DEF. Okay, it's this one. We can outline it like SWA. Okay, they have the same angle D, so we can use that to our advantage, but you can already see there's going to be problems if we are not careful. First, we need to find what is the ratio of that side over that side. Okay, that's what we need. That's what we need. Once that is sorted, then we are free to go. So I think we need to start this question on a different page. Okay, so we have 18.2. Now with 18.2, we want to start by saying DH over HF is going to be equal to essentially DK over KE. Nice. So this is now the proportionality theorem in triangle DEF with HK parallel to EF. Yeah, we used B there, so we know, folks, that this is 2B and 2B, so DA, did I say DH? Oh yeah, DH over HF is going to be DK is 2 times B, so this is basically 4B divided by 1B, isn't it? That one is done. And so what is next? We can then conclude, if we cross multiply there, that DH is going to be equal to 4HF. That is fine. We just want an equation. So you can say then area of triangle DGH divided by area of triangle DEF is going to be a half DH DH, yeah, times actually I chose the wrong triangle. It was that small one that we needed. Okay, not a problem. It's going to be DH times DG times the sine of that angle D, we can call it GDH, all divided by half DE times DF times the sine of angle GDH. I'm just wanting to write it the same way so that that and that goes. Always aim for some elimination so that the whole thing becomes painless. DH, we're going to write it as DH times DG. DG, we saw that it is 2B divided by DE. Now we can see that this is nothing but 5B times DF. DF is going to be is going to be GH plus HF. Hey, ke maketse jwale izoba ngubani ke? Sothi lena izoba ngu-DH plus HF. Okay, izostrika kancane, but we're gonna be fine. DH times 2B. I should have used symbols. It would have made my life easy. 5B into, now DH is 4 times HF, isn't it? So HF is a quarter of DH. Now what do we want to do? Well, we want to substitute this guy with 4 times HF. Right, so that we go again, say 4 times HF plus HF. Okay, siyawina mos. So 4HF times 2B all divided by 5B into, this one becomes 5HF. Now we can do the things. HF will take HF, B will take B, and then we've got 4 times 2, that's 8 over 5 by 5 is 25. See, guys, I hope this is good. I confused myself along the way. But in maths, guys, you play with the things. You see, this was golden. It helped us to really sort out problems. Okay. So that you can see clearly. All right, guys, I'm still not making much progress, hey? I'm really not making much progress. I'm worried. I am really worried. Maybe we should leave these other questions for later. Maybe a third video. 1, 2, 3, 4. Anyway, guys, I think it's fair to stop. We tried, but I'm gonna lose time. I need to get ready for my class. I need to eat, so that by the time I start, it's quite a lot of questions. 1, 2, 3, 4, 5 questions. Hayi, senze zingaphi? 1, 2, 3, 4, 5, 6, 7. We did 7 questions. I think that's fine, because these questions are taxing, guys. If I do another one, then the next video is gonna be boring. It's gonna be short. I think let's cut it here. This is the end of these questions. Right, so let's see, what is the story now? We want 4 marks, so obviously statement and reason. Important. Setting up the area rule here. And we can say the major substitutions and the final answer. How many marks was this? 4. So it looks like 1 mark for statement and reason. And everything seems fine. Okay, so that would be it for just 7 marks, guys. As you can see, yasetyenzwa bafethu. Siyaspana asidlali. All right, folks, let us cut it here so that the video is not too much, because now I have to do a class and I use the same tablet. If I was using a different one, I was going to pause, go to my class, and then come back and finish up. But now I'm using the same gadget. My phone is too small. I don't want to use my phone for my classes because, yeah, the tablet does a good job. All right, guys, stay tuned to the third video where we are going to do the last few questions or so. Hope you liked it and you've learned something. I will see you in the next one. Goodbye for now.